Alright, so in this one we are going to understand a very basic and important topic, logarithms. So what are logarithms? Well, the name may seem a bit fancy, but they are just the inverse of exponential functions. So nothing special about logarithmic functions. So to understand logarithmic functions, we just need to understand how exponential functions behave. Once we are done with that, everything about logarithmic functions becomes crisp clear. So let's try to understand this. So let's try to understand exponential functions first. And for that, so let me jot it down. So we'll talk about exponential functions first. We are pretty familiar with this. They come in two families. The first family is the ones with base less than 1. Base has to be positive. So this is characterization of first family. And the second family comes with base greater than 1. We can put a name on them. So this one I will call them decreasing family, and this one is increasing family, and we'll understand why these names are attached to them. So the graph on this side will look like an increasing curve, and graph on this side will look like a decreasing curve. So that's why we have put this label on them. And so let's take some typical examples of these families. So let's start with base greater than 1. They are a little bit more frequent. So let's pick 2 power x. So this is a typical exponential function. So this thing is called base, and power itself is the input, and y is output in this case. So this is a typical exponential function, and if we try to plot it on graph, let's do that. So this will be the input axis, this will be the output axis. So if I just collect some points from this equation, we see that if I place x0, y is going to be 1. So I will put it here, and if I put in x to be 1, then y is going to be 2. So that means at 1 it's going to take 2 values, so it's going to come here. So let me put a dot here, and then at x2 it's going to be 4. So at 2 it's going to go somewhere here, and so let me put a dot here. Let's say this is the point 2, 4. And similarly, if I go on placing negative values of x, I get at x is equal to -1, I get half. So that means dot is going to be here. At -2, it's going to be 1/4. So we get the idea that if I join all these points, our graph is going to look like this. So this is y is equal to 2 power x, and it hits y-axis at 1. This point is 1. So we can see that this curve is increasing curve. As x is increasing, y goes on increasing. So that's why we have put this title on this family, which is that's why it's called increasing family. And this is a representative of this family. If we pick any other base greater than 1, the behavior is going to be same. Let's say I'm talking about y is equal to 3 power x. So the only changes that is going to happen here is that it's going to rise a bit more sharply, because here it's going to pass through 0, 1. So this point will be same. But at 1, that one is going to generate 3. At 2, that one is going to generate 9. So it's going to go like this. So bigger base will make it rise more sharply. So if I want to just plot it here, then this thing, I can say that this thing, this one will be y is equal to 3 power x. if I choose my base to be 1.5, so that one will go somewhere here, and it's going to lie here, so it will look like this. But the main thing here is that every curve belonging to this family with base greater than 1, it's going to be increasing. And all those curves, they intersect at 1. So this is one family we are interested in. We are talking about exponential functions. As I said, they come in two families, greater than 1, less than 1. So typical representative here, this side is 2 power x. And so let me get rid of this. Let's keep it clean. We will just take one representative, 2 power x. And on this side, again, let's take this as x and y. And let's choose a representative to be y is 1 by 2 power x now. So this is going to be a representative for the decreasing family. So here, if I start placing the values, I put x0, I get 1. So this point is same. This is being shared. This curve also passes through 0, 1. So this is okay. And now if I put x1, then I get half. So it's going to land somewhere here. And if I put x2, it's 1 by 4. So it goes like this. And if I put x is equal to -1 here, so that will generate 2. So that thing goes here, and at 2, -2, it goes to 4. So that means it's coming like this. Passes through these points. And so this thing, we can see that is a decreasing curve. And same thing will happen if I change my base to, let's say, 1 by 3 power x, then it's going to sit somewhere here. So all the curves with base less than 1, all the exponential curves with base less than 1, they are decreasing curves. So these are two typical families in which we divide the exponential functions. So they come in two families. These are the two families. And let's not stray from our main subject, main topic, logarithms. So we want to understand this. As I said, this thing is nothing special. If I understand what is exponential function, which means if I understand how this behaves, y is equal to 2 power x, how this behaves, y is half power x, then I'm completely in control with how logarithmic function will behave. So there is nothing special with this. So now what is logarithm? Again, because they are inverse of exponential functions, they will come in two families. So let's pick one for now. Let's say I want to understand what are corresponding logarithmic functions for this family with base greater than 1. So I will pull it here. So I'm assuming my base is greater than 1. And we have seen that a typical member of this family looks like this. The graph is increasing, it passes through 1. And if I plot y is equal to x line on this graph, so let's say this one is y is equal to x, then I can look for the image of this function. So let me label it. So this one is y is b power x. B here is greater than 1, that's why it's increasing. And if I just take an image of this function, of this graph in this line, and this line is y is equal to x, then I will get a new curve, which I'm drawing with this blue line. And obviously it's going to pass through 1, 0, because this one passes through 0, 1, so this passes through 1, 0. And it's exact image, so only x and y values are exchanged. If there is a point x comma y here, let's say p comma q point is lying on this curve, then its image will be just q comma p. So that's how switching is happening. So this lands here, and this portion lands here. So we have just taken the image. and this curve was going close to x-axis when it was moving towards negative, and this one now will go close to y-axis as y goes negative. So this thing, so this new curve that we have obtained, this is called, so let me not use equation at this point. This thing is called logarithmic curve corresponding to base b, or this exponential curve y is equal to b power x corresponding to, let me just write it, b here. And instead of saying all this gibberish, I'm just going to say, I will just put it as, instead of this, I will just use some notation, and that notation is log x, and base we hide here. So this thing is retained here, and this is just a notation, log of x base b. So this is the meaning of logarithm. Let's try to understand by taking some values. So let's talk about a simple question: what is 2 power 3? When I pose my question like this, we know the answer, it's 8. But when I pose my question like this, I'm interested in this output, and this format we label as exponential format. But I can also ask same question in a bit different manner. I can ask, what power of 2 gives us 8? When I ask this question, this is called logarithmic format. So that's the only difference where this question mark is placed. So we have just inverted this equation over here. That's the only difference, and that's what is happening in this graph over here. And a neat way to write the second equation is, because this looks very funny to place the question mark at the top. So here it's okay, it's on the line, but if you want to bring this on the line, then I can also write this in a new notation, which will be that log 8 base 2. So this base is retained here, as I mentioned earlier, and this is the input. In this case, input goes here, and this is the expected output, it goes here. So this is what basic idea of logarithms is. So we are going to get deep into this in next one, where we'll describe both the families of logarithms corresponding to increasing exponential and decreasing exponential. We'll also draw graphs for these things. But in this one, I just wanted to convey the basic idea, which is very important and very easy to understand. There's nothing to learn here, and there's nothing to mug up. People go about learning formulas for logarithms and I don't know what, but that's absolutely not required. So if you understand how exponential functions behave, so then we totally are in control of this thing. So we'll see that in the next one. Right, so that's it for now. See you in next one. Bye-bye.